Okay, so we're looking at regression. Sabi natin, ang regression, ginagamit natin yan in order to establish the relationships between variables. No, one is a dependent variable, and the others are the independent or explanatory. Gusto natin malaman kung may relationship or may influence or may impact ang independent variables on the dependent variable. We're not saying that it causes, no, the independent variables causes the dependent variables. Sinasabi lang natin, tinitingnan natin yung relationship ng mga variables na to. Just move this. So last time, tinignan natin itong mga measures na to, SSR, SSE, SST. Sabi natin, importante to kasi this is the basis of the method of ordinary least squares. No? And yung R squared, which is ito yung ano pala, yung SSE, yung deviation ng actual value of our dependent variable minus the predicted value. Yung predicted value is based on our model. Pag in-square natin siya tapos sinum up natin siya, dapat minimum to. No? So sabi natin, wala nang ibang regression line na mag-fit given your data points. So kunyari guys, in our case, education and hourly wage, there can only be one regression line for this data set. Pagdagdagan natin ng, kunyari, dinagdagan pa natin to ng more observations, mababago yung regression line natin. No? Kasi unique yung regression line for each data set. Itong 526 observations na to, for education and hourly wage, there can only be one regression line. And what we did last time was to use Excel in order to generate our regression output. Okay, so this is our simple regression output. Sabi natin 3 parts dito. 3 parts, yung regression statistics, yung ANOVA, at saka yung coefficients natin. So we haven't discussed these coefficients. Okay, so let's discuss it now. So a quick review lang guys. Sabi natin, itong first part ng regression output in Excel, this gives us the first number here, multiple R is your correlation. No? This is the correlation between the independent variable and dependent variable. The higher the correlation between your independent and dependent variable, the better. No? Mas maganda yon. Then R squared is the coefficient of determination. Sabi natin, 16.47% of the variation of your dependent variable can be explained by your independent variable, in this case, yung education. So 16.48% ng variability ni hourly wage can be explained by education. Now itong adjusted R squared, this is more relevant guys kung multiple regression tayo. And the formula for this one, sulat ko lang dito, is we write it as R squared. No? May line dito. That's adjusted R squared. And it's equal to 1 minus R squared times N minus 1 all over N minus K minus 1. Okay, so this is the formula for your adjusted R squared. And it's dependent on your R squared. No? Okay, itong factor na to, N minus 1 over N minus K minus 1. Take note, kapag yung K dito yung number of regressors natin, number of explanatory variables. So your adjusted R squared is dependent on 2 things, no? Yung N, yung size natin, at saka yung K. Okay? Pag malaki yung N, guys, kunyari hundreds of thousands yan, baliwala ito, no? Baliwala ito. So your adjusted R squared will be just the same as your R squared. Hindi masyadong relevant yung yung ano natin, yung adjusted R squared. No? However guys, kung hindi malaki yung n tapos malaki yung k, then maaapektuhan yung ano natin, yung adjusted r squared. So ginagamit yung adjusted r squared guys when you're doing multiple regression. Okay, so let's compute here guys. So this is equal to 1 minus r squared natin ito. Okay, so this would be times n minus 1. Ano yung n natin? N. This is n minus 1. Okay, divided by n minus k. Ano yung k natin guys? Our k is the number of regressors. Diba? In this case, 1 lang siya. No? And then minus 1. Enter. Mali yata. R squared 1 minus. Baliktad yata yung ano ko, yung formula. Sorry. It should be sorry guys, dapat yata, my apologies. I got the formula mixed up. It should be dapat nandito yung minus 1 sa dulo. Oops. Digital pen is not working well. Okay, baliktarin natin guys yung ano, yung formula. Okay, so it should be minus 1. Wait. Sorry. Ano sa formula ko? Tama ito kaso sorry guys 1 minus ito na yun Okay, let me recall guys the formula. It's n minus 1 over n minus k minus 1. 1 minus r squared minus. Okay, sige, check ko muna guys sorry. Nakalimutan ko yung formula no. R squared. Pero tama itong factor natin na to. Okay, let me get back to that in a while. Alright, so kahapon tinignan din natin tong ANOVA natin, no? Yung degree of freedom, sabi natin, ng regression will be the number of independent variables. Yung degree of freedom ng residual natin, it's n minus k minus 1. N is the number of observations. K is the number of your regressors. So if you have 10 independent variables, that should be n minus 10 minus 1. Okay. Yung minus 1 dyan, guys, that's the degree of freedom lost for the intercept. Okay. Kasi ini-estimate din yung intercept So pag nag-i-estimate tayo ng parameter, nababawasan yung degree of freedom natin. Okay. And the total degree of freedom is simply n minus 1. Okay. So we looked into this last Monday, di ba? Yung SSR, naalala niyo yung formula nito, guys? SSR, regression natin, is this one. It's your predicted value minus the average value. Kasi we're comparing the predicted value based on the regression and the average value. Kasi ito yung ano natin guys, kung hindi natin gagamitin si X, yung independent variable natin, then we will have to resort to using the average of Y. So si Y lang ang ano natin, si Y lang ang model natin. So for example, magpe-predict tayo magkano yung magiging hourly wage. Whatever the situation is, kasi hindi natin gagamitin si X, no? It will always be the average of Y. Pero since we were using a variable which is x in order to explain y, then we were able to come up with a model, a regression model, and from that we have a predicted value. So yung difference ng predicted value is minus the average is actually the improvement of your model. No? Nag-improve yung model from just being the average of the dependent variable. Nagkaroon tayo ngayon ng predicted value where we're using another variable y. Okay? So this is what we call the sum of the squares due to regression. Ito na ngayon, guys, ito na tinatawag natin na explained variance. No? Na-explain natin yung variance. And then yung SSE is the difference between your actual minus your predicted value squared. Sum yan, this is your unexplained variance. So we did that last time, last Monday. So SSR, SSE. So notice guys, malaki pa yung SSE, ano, yung residual. Ang kaya lang i-explain ng model natin, 1179. Ito, 5980 yung hindi kaya out of the total 7160. Okay, so you get the proportion of this 1179 divided by 7160. Yun yung r squared natin. Okay, yun yung r squared natin. Tapos mean square of your regression and mean square error, it's just the quotient of SSR divided by the degree of freedom. And then from so ito yung MSR divided by MSE. This is your MS. Edit nga natin comment natin dito. Edit comment. Hindi ko nalagay dito. This is your MSR. And this is our MSE. MSE. Okay. Remember guys, yung MSE, ito yung source ng standard error, no? Okay? Ito yung source ng standard error. So ito yung ano, yung hindi kayang i-explain mean square error. Okay? So we use this in order to compute your standard error. So magkalink yung dalawang yan, no? So square root of this is your standard error. The lower your standard error is, the better guys is the model. So kunyari mataas tong SSR natin, mas mababa tong SSE natin, maganda yon guys. Kasi kayang i-explain ng model natin yung variation ng dependent variable natin. Okay? And last, by the way guys, sa Excel, itong last ano natin dito, no? Yung significance F. So yung F statistics natin, ito yung ginagamit natin para malaman natin kung significant yung overall yung goodness of fit natin. Ano yung goodness of fit natin, guys? Ito yung null hypothesis nun. Okay? So our null hypothesis is that yung mga parameters ba na ini-estimate natin o ginagamit natin in order to explain our outcome variable or our independent variable, which is BO and B1, yung parameters natin, are they all equal to 0? So we base our conclusion on the p-value. And sabi natin, when the p is low, the null must go. So ito, ano yung low? Ang low natin will be the level of significance. So this is called your level of significance. No? So kino-compare natin yung p-value natin sa alpha na 0.05. If it's below 0.05, then the inference is we reject our null hypothesis. Okay, there's strong statistical reason to believe that at least one of this is not equal to 0. Tapos sa Excel, guys, paano natin compute to? Sa Excel, we can use the F dot. Okay. Ito kasi guys, probability yan, no? Let's go out of this. Okay, if you recall guys from your earlier statistics, yung F distribution, ba't kaya ganito yung digital pen ko? Parang may problema yung digital pen ko. Hindi siya nag-exact. Okay, so we have this plot, no? This is how your F distribution looks like. Yung tail niya andito sa kanan. And then you have your FStat 103.363. Tapos gusto natin malaman ano yung probability na to. This is your P. Okay? Dapat yung probability na acceptable sa atin is 0.05. That's our level of significance, which is your alpha. So based on the F value of 103.363, ano to? What's the value of this? So we can compute for that dito is equal to F dot this. Okay? And it's right-tailed. Right-tailed naman yung F-stat natin. Okay? So yung X natin is your F statistic. And then your degree of freedom this is your degree of freedom of your regression, 1, and degree of freedom of your residual. So that's how you compute it in Excel. F.this.rt. Enter. Okay, so you see that they are exactly the same. No? All right, then we have this third part, the parameters, the coefficients. So ito binibigay sa atin yung value ni intercept at saka ni education. We have met this, guys, several times na. Ito yung intercept, ito yung slope. Di ba? Kinumpute na natin si intercept at saka si slope. And then you have your standard error. And then your t-stat, which is just your coefficient divided by the standard error. And then you have your p-value. Sorry. And delete ko muna ito class kasi sa Excel na uulit yung upper and lower. Let me just clear that. Okay. And then the p-value. Now, this tells us kung significant yung parameter natin. In this case, the intercept, the p-value is 0.18. So what's our conclusion? First, we know that may null hypothesis tayo dito, guys, no? Ang null hypothesis natin dito, H null is, this is your beta null is equal to 0. Dito naman, null hypothesis natin, beta 1 is equal to 0. Okay, so this is our null hypothesis for this statistical test. So we're testing kung yung intercept natin, which is your beta 0, is it significant? No? So ang basis natin, either yung t-stat or the p-value. Okay, so i-base lang natin sa p-value kasi ito yung kitang-kita natin. No? So we compare this with our alpha, which is 0.05. Okay, and this is greater than alpha. Sabi natin, kailan lang natin i-reject yung null hypothesis? When the p is low. But this is greater than alpha, so ang conclusion natin, we fail to reject, no? Fail to reject our null hypothesis. HO1, HO2. We fail to reject this, no? This null hypothesis that HO1 or beta sub 0, which is intercept, is equal to 0. Okay? In fact, guys, makikita natin dito yan. Sa lower 95% at saka sa upper 95%. Sabi natin, ang possible values ng beta 0 natin is between negative 2.2 at saka 0.44. Tanong guys, possible ba na tamaan si 0 dito? Okay, shout out na lang guys. Pwede bang tamaan si 0 dito? Is 0 in between these two values? Guys?
Yes, sir.
Yes, oh, yes. So, there's a possibility that your beta null, your intercept, is equal to 0. Kasi, ito yung ano natin, no? Yung confidence interval natin, it's between negative 2.25 at saka 0.44. No? Okay, thank you, James. Okay. So, possible guys na maging 0 yung beta 0 natin. Okay, that's why we're rejecting the null hypothesis that beta, we fail to reject this kasi may possibility na maging 0 yung intercept natin. However guys, does that mean na hindi na natin isasama to si intercept sa model? Hindi. Pag yung intercept guys, whether it's significant or not, ang practice, we still include that in your model. But not the independent variable. No? Kung yung independent variable hindi significant, then hindi natin isasama yun sa ano natin, sa model natin. Okay, let's take a look at education naman. Education is our beta 1, di ba? Ito yung beta 1 natin. Ang null hypothesis natin, beta 1 is equal to 0. Looking at your p-value, 2.7 times 10 to the negative 22. Ang ibig sabihin niyan guys, decimal point, tapos 1, 2, 3, 21 zeros, tapos 278. Yan yung p-value na yan, no? It's written in scientific notation. Times 10 to the negative 22. Ibig sabihin ng 21 na zeros, tapos saka lang lalabas si 278. So this is practically 0, guys, di ba? It's way less than 0.05. So ang conclusion natin dito, guys, we reject the null hypothesis. Reject. We're rejecting this hypothesis. Reject natin itong hypothesis na to na beta 1 is equal to 0. There's strong statistical reason to believe that beta 1, okay, is not equal to 0. In fact, if you take a look at this, yung confidence interval natin, it's we're 95% sure that the true education value lies between 0.44 and 0.65. Okay, so tatamaan ba yung 0 dyan? Hindi. No way that 0 will be between these two values. Okay, kaya nga rin reject natin itong hypothesis natin. So later on guys, sa mga research nyo, pag nagre-regression kayo, bawat isang independent variable may hypothesis yan. Okay? So ano interpretation ito? Well, we have our equation. Ginawa natin ito dati. Hourly wage is equal to negative 9.90405 plus 0.541 times education. Okay, ano interpretation ito, guys? Interpretation of this. For every 1 unit increase in education, ang education natin in years, kaya sinasabi natin, for every 1 year increase in education, there's a corresponding 0.541 increase in hourly wage. Kasi ito guys, ito yung marginal effect, no? Marginal effect ng independent variable na to on our dependent variable, 0.54. So pag nag-increase daw ng 1 year of education, nag-i-increase yung hourly wage ng 0.54 on the average, no? On the average. Then sinasama natin doon yung statement na ceteris paribus. Ceteris paribus. Ano ibig sabihin ng ceteris paribus? All things being equal or all other factors remaining the same. This is more important guys pag multiple regression. Kasi pag multiple regression, tinitingnan lang natin yung mga individual effects of the regressors, of the explanatory variables. Then kino-consider natin yung variables constant lang. Ang babaguhin lang natin yung specific na independent variable na yan. Okay? Then later on guys, sa mga ano nyo, sa arts, sa FINSTAD, pag-aaralan nyo pa to, no? Ang importante dito guys, hindi lang dito natatapos. We have what we call as diagnostics, no? Dinadiagnose natin yung model natin, no? ang tinitingnan talaga natin dyan, yung residuals. Kaya ina-analyze natin yung residuals, yung error terms. For example, dapat yung residuals, dapat normally distributed. Kung titingnan natin ito guys, yung normal probability plot na to, mukhang hindi siya normally distributed kasi dapat, imagine there's a line here, hindi lang masyado maganda yung sa Excel, no? Imagine there's a line here, dito. Dapat yung mga points niya, dapat malapit dun sa line. Ito mukhang malayo, oh. Malayo siya. Okay? So there are still other diagnostics which we're going to discuss in a while pag nagpunta na tayo sa R. Okay? So, let's now go guys to, well, dito guys, andito yung observation. Tapos ito yung predicted hourly wage, which we got here already. Kunyari 5.05 to. Sinog na actually natin yan, di ba? Ito, yung predicted value. Tapos itong residual, negative 1.95. Ibibigay na rin sa atin ni Excel yan. Ito, negative 1.95. Then we have here the standardized residuals. Okay, then here you have the plot of your residuals. No? Okay, ang nature dapat ng residuals, guys, dapat wala siyang pattern. Okay, wala siyang pattern. Ano ibig sabihin ng pattern? Let me just highlight that. Pag yung residuals natin, kunyari, pag prinat siya, medyo pataas. Okay, hindi maganda yung model natin. Dapat yung predicted, yung residuals natin dapat random lang, no? So ito mukhang okay naman. Pero pag kunyari ganito yung plot ng residuals natin, may pattern siya. Ang tawag dyan guys, heteroscedastic yung yung heteroscedastic yung error terms natin, yung residuals. Okay, we don't want a heteroscedastic distribution of your error terms. Gusto natin homoscedastic lang. Okay? Ang ibig sabihin ng homoscedastic, constant mean, okay? Yung average siya constant lang, siya constant variance. Ito guys, medyo may problema kasi mukhang tumataas, oh. Tumataas yung natin, yung variance, no, ng residuals natin. Habang lumalaki number of years sa education, lumalaki yung yung variance niya. Dito maliit lang yung variance dito sa siguro 6 or 7 to or 8. Pag dumadating guys, pag lumalaki yung education natin number of years, lumalaki yung variation niya. Okay, so this is an example of what we call, parang may fanning out to, no? Ano yung fanning out? Yung fanning out guys, yung residuals natin parang ganyan. As the value of your independent variable of your model increases, yung residuals natin lumalaki. So that's an example of a heteroscedastic residuals. So pag ganyan guys, later on sa sa next subject nyo, i-address niyan kasi hindi pa pwedeng ganyan. Hindi acceptable yung model pag ganyan. Okay? So any questions so far? Pause muna ako. Any questions? Any clarifications? Okay, by the way guys, hindi natin matatapos lahat to. And there's another topic which I want to discuss. Now, I hope you can attend sa Friday, same time na lang din. Siguro kung pwede gawin natin 9, pwede 9 to 11. No attendance will be checked, but I hope you could come. Kasi ipa-finalize ko yung discussion nito. Tapos plus the last topic, no? I would really encourage you to attend that kasi i-discuss ko guys yung a very important package na makakatulong sa inyo, especially in regard to finance, no? So I hope you can be there. So that's a Friday at 9 o'clock. Okay? Again, attendance will not be checked, but I'll record the proceeding. But I hope you can be there, guys, kasi iba yung nakikita nyo rin habang ini-explain. Okay, so let's go here, guys. Okay. Now let's go up to multiple linear regression. So so far yung dinidiscuss natin guys, it's just simple linear regression kasi merong iisa lang tayong iisa lang yung dependent variable natin, isa lang yung independent, tapos of course isa yung dependent. Pag regression guys, laging iisa lang yung dependent variable natin. Alright, then we have this, no? Taken from the same data set. Ito education natin. Gawin din natin itong HR wage, hourly wage. Oops. But now, okay, we'd like to explore what if we use these other variables, no? So, yung respondent na to, si ID number 1, 11 years of education siya, 2 years of work experience, tenure kung ilang na siya katagal dun sa job na. So, bago lang siya dun sa job niya, ito, although current job niya, no? Although may 2 years experience siya, ibig sabihin 2 years na to dun sa ibang company. Ito namang taong to, 8 years of education, 44 years of experience, 28 dun sa current job niya. And then, yung race natin dito, may mga non-white at saka white. Yung gender, female at saka male. Civil status, may single, may married. Number of dependents, ilan yung anak, saka hourly wage. Okay, now, we have now 1, 2, 3, 4, 5, 6, 7. 7 independent variables and 1 dependent variable. This now calls, guys, for a multiple linear regression. Now, okay lang tayo dun sa quantitative variables, no? Ang problema natin, itong qualitative variables natin, which we call as factors, no? So, itong factor, pwede ba siya maging independent variable? The answer is yes, no? Is yes. Kaso sa Excel, kailangan natin i-convert muna. Kailangan natin i-convert to kasi hindi pwede mabasa ni Excel yung qualitative na yung character na to, no? So, kailangan natin i-convert to into what we call dummy variables. Okay. May rule guys in using factors. Pag sinabing factors guys, dummy variables used for factors. Ano yung factors? Factors are categorical variables, okay, which we use to classify your respondents. So, kunyari yung race. Meron kang white at saka non-white. So, this is a factor. Okay. Hindi lahat, guys, ang character variables or qualitative variables, factors. Factor lang siya, guys, kung pwede siyang gamitin as a classifier. Kunyari, pwedeng location. Kung saan ba siya nakatira. Kunyari, sa Metro Manila, Makati ba, Pasay, etc. That can be a factor. A year level, that can be a factor. Gender, female, male, that can be a factor. Okay? So there are many variables that are qualitative that can be classified as factors. Pero maraming hindi rin. No? Kunyari, address, yung complete address mo. Unique naman yung mga taong yun, guys. Diba? Kunyari, you have kunyari, 1,000 respondents. Magkakaiba naman silang, they belong to different families. So, hindi natin pwedeng gamitin factor yung address kasi magkakaiba naman yun sa bawat isang tao. Okay, you get me, guys? So, ang factors are, they are qualitative, okay, character variables, qualitative variables that can be used to classify. Okay, clear? Pause muna ako. Clear ba yung guys, yung factors na yan? Paki-chat na lang, guys, kung yes or no. Okay. Yung iba, pwede. Thank you. Okay, thank you. Alright, so factors na na. So sa Excel, guys, kailangan i-convert muna natin to. Okay. Let's copy this, guys. Control, tapos yung mouse nyo. Go here, control, and then mouse, left click nyo, and then drag nyo dito. Yan, so kinopy ko siya. para ma-preserve ko lang tong worksheet na to. Okay, dito. Alright, tatanggalin natin to, guys. Okay, dito sa ano natin, sa dataset natin, may instructions sa dito, no? So ito yung metadata natin. This is called your metadata. Metadata. What's metadata? It's information about your dataset. Data about the data yan. So metadata is data about the data. This is our data. What's our data about the data? So ito yan, no? Wage. Gawin natin hourly wage to. We change this, di ba? Oops. Hourly wage. Small letter lang. Education is use of education, etc. No? Now, kung gusto natin, si non-white, guys, gagawin natin 1. Si female, gagawin natin 1. At saka si married, gagawin natin 1. This is arbitrary, guys. Pwede nyo gawing si white yung 1, si male yung 1, si single yung 1. It doesn't matter, guys. You'll get the same result. However, we have to do that. We have to set one of them as, ang tawag dito, guys, okay, si non-white, 1. Therefore, sino yung 0 dito? Sino yung 0? Kung si non-white 1, sino yung 0? Si white. Okay? Ang tawag kay white, guys, this is your base or reference variable. Kung sino ginawa nating 0, siya yung base or reference variable. Okay, tanong. Ilang factors, guys? Ilang factors si race? Paki-chat nga. How many factors do we have for race? Pag sinabing factors, ilang classifications? Kindly chat, please. Kay factor, ilan yung ano natin? Kay gender, ilan yung factor natin? How many? Yeah, correct. David, thank you. Dalawa, no? Bakit? Thank you, Anton. Yes, correct. Dalawa. Bakit dalawa, guys? Kasi dalawa lang naman yung classifications natin. Okay, pag tatlo yan, then tatlong factors. Okay, now that's important kasi yung dummy variables natin na i-insert, okay, will be equal to problema itong ano ko, yung digital writing pad. So the number of dummy variables will be equal to the number of factors minus 1. Okay? So for example, for gender, ilang dummy variables ang ilalagay natin? The number of dummy variables is equal to how many factors for gender? 2 factors and minus 1. Minus 1 lagi. Okay? So therefore, how many dummy variables are we going to insert for gender? Isa lang, guys. Isa lang. Bakit? Dalawang factors minus 1, so that means 1. Okay? So how do we do that? So sabi natin, ay, what happened? Ba't ko na-delete si Tenyo? Dali hindi ko dapat i-delete si Tenyo. Dapat ang i-delete ko si Mary. Okay? So sa Excel, guys, ang gagawin natin, sabi natin, si non-white, gagawin natin 1. Tapos, of course, si white, magiging 0 yan. Dito naman, guys, si female, gagawin natin 1. Kaya linagay ko na sa taas kung sino yung gagawin natin 1. No? So this becomes now non-white. So in other words, guys, si race, papalitan natin ng dummy variable yan. Ilang dummy variables? Isa. No? Isang dummy variable. And sabi natin, ang gagawin nating base or reference factor, si white, Therefore, si non-white ang ilalagay natin. Si non-white yung 1, si white yung 0. Dito, si female yung 1, si male yung 0, si married 1, single 0. Okay, so easily guys, madali yan sa Excel. If our gender, if this is equal to, the gender, if yung race natin, ito, is equal to, sinulat na natin dito, no? Okay, non-white. Then we have to fix the column, guys. We have to fix the row. Sorry. We have to fix the row kasi i-copy natin to guys pakanan, no? Pag kinopya natin pakanan natin, gusto natin lumipat siya dito kay female. Okay? So, please apply me guys with the value here. If this value is equal to non-white, what are we going to give it, guys? Anong value ilalagay natin? Tingnan nyo guys. Non-white daw is equal to non-white. Yan, correct. Thank you. Thank you, Nicole. 1. Tama. No? So, 1 siya. No? 1. Otherwise, anong value ilalagay natin? Otherwise, correct, 0, no? Otherwise, 0 siya. Sige, check natin ha. Otherwise, 0 siya. 0. Close. Alright. So, itong formula natin na to, pwede na to, no? Kasi pag rinag ko dito to, pupunta naman dito kay female yan, tapos pupunta dito kay single. Okay, sige. So, check ba? White. Kung non-white 1, white siya, kaya 0 siya. I copy this to the right. Female 1, tama. Single, married, 0 siya. So we can now just, there. Okay, pause muna ako guys. So, ito guys, na-convert na natin yung categorical variable natin into numerical variable. No? Binary siya, 1 or 0 lang. So, pwede na natin magamit ito sa regression, sa multiple regression natin. Okay, clear so far, guys? Clear so far? Okay, thank you. All right, so let me just illustrate this, no? Kunyari, meron tayong may data tayo na year level, no? Year level. Sample lang to, year level. So, kunyari, nag-interview tayo, may frosh, may interview tayo sophomore, may junior, may senior, kunyari ganyan, no? May senior ulit, junior, frosh, sophomore, junior. Okay. So ito yung natin guys, ito yung categorical variable natin to, no? Now can this be treated as a factor? Pwede ba natin gamitin yan sa regression? Kaya nga sinasabi ko sa inyo guys, yung pagpipili kayo ng data para sa project nyo, gamitin nyo guys yung yung may factor din. Guys, pwede ba natin gamitin to as regressor? Answer? Pwede. Kasi factor to guys no? Factor siya. Ang question natin guys, ilang dummy variables ang i-introduce natin? How many dummy variables are we going to introduce? Anyone? So sabi natin, di ba, pag factor siya, pag pag qualitative na factor, pwede natin gamitin sa regression yan. But we have to introduce a dummy variable. Now question, ilang dummy variables ang introduce natin? Anyone? Di ba? Ito yung formula, guys. No? Yung dummy variable na introduce natin is the number of factors minus 1. So ilang factors to? We have 4 factors. Frosh, sophomore, junior, senior. You have 4 factors. So ilang dummy variables ang introduce natin? 3 lang, guys. Okay? Thank you. Yes, correct. Nicole, thank you. You're correct. 3 lang, guys. Magkakamali tayo, guys, kung 4 na dummy variables ang ang i-introduce natin. So how do we do that? So for this example, let's use our base. Gamitin natin si base, si Frosh. No? Ang base natin si mga Frosh. Example lang. Therefore, guys, pag base si Frosh, ibig sabihin 0 yan. The rest will be 1. So, sino-sino yung mga dummy variables natin? Meron tayong for sophomore, meron tayong for junior, meron tayong for senior. Take note, guys, hindi natin ipapasok sa dummy variable natin si Frosh. No? Of course, guys, pwede rin ang base nyo sophomore, pwede rin ang base nyo junior, pwede rin senior. It doesn't matter. As long as may base lang tayo, no? Tsaka introduce lang natin minus 1 yung dummy variables natin. So, sige, let's do this. So, sabi natin, pag sophomore siya, 1 siya. No? Otherwise, magsi-0 dito yan. Pag J siya, 1 siya dito. Pag SR, guys, senior, 1 siya dito. Okay, sige, tingnan natin ha. Si Frosh, guys. So, if this is equal to, now we have to fix this. If you fix natin yung column, kasi dapat dito lang siya, no? If that one, check ko yung kanina. If that is equal to this, dapat naka-fix yung row. Value 1. Otherwise, 0. Okay? So that's our test, no? So notice, guys, 0 siya. Pag dinal natin dito, 0 din. Pag dinal natin to, 0 din. And if we copy everything, okay. So let's check, guys, kung tama. Frosh ba to, guys? Itong respondent na to? Yes. Kaya hindi siya senior, hindi siya sophomore, junior, senior. Si sophomore, ito, is he a sophomore? Yes. Kaya tama, 1, 0, 0 siya dito. Junior ba to? Kaya 1 siya dun sa J. Senior ba to? 1 siya dun sa senior. Okay? So that's how it goes, guys. No? Si Frosh. So hindi na natin kailangan, guys, sa isa pang dito na Frosh. Kasi just with 3 dummy variables, guys, makaka-capture na natin lahat ng information na yan. Kung mag-apat pa tayo, magkakaroon tayo ng problem, guys, sa regression. And that's what you call, hindi ko na-explain ng masyado, pero ang tawag dyan, guys, pag, kunyari, 4 yung ginawa mong naglagay ka pa dito ng frosh, no? Naglagay ka pa ng frosh dito. So ito magiging 1, 1, 0, 0, etc. So you have 4 factors, tapos 4 dummy variables. Magkakaroon tayo ng problem dyan, which we call dummy variable trap. Okay, dummy variable trap. And the details of that, guys, you'll discuss when you go next time nyo pag nag-ano na kayo. So, pause muna ako, guys. Clear ba? Paki-chat naman kung okay so far. Any questions? Thank you, Anton. Thank you, Stephen. Okay, thank you, Nicole. Okay, so the rest, guys, I hope clear. Okay, so let's now go to our ang gamitin natin, guys. So to preserve yung ginawa natin para may reference kayo, no? Gamitin natin tong MLR natin. So take note, ito, tinanggal ko na yung formula, no? Tinanggal natin yung formula. Hindi natin pwedeng gamitin yung may formula. Magkaka-error tayo pag nag-regression tayo. Okay, clear so far, guys? So this is hourly wage. Hourly wage. Okay, before we proceed, guys, could you kindly check, guys, kung Control M, ayaw ah. Nangyari sa ano. Okay, sandali, guys, naglolo ko tong ano ko. Alright, paki-check, guys, kung Control Alt T I ba? Control T I. Hindi. Ang shortcut mo, nakalimutan ko, Alt T I. Ayun, okay. Sige, guys. Kindly check, guys, kung mag-control M kayo, kung lumalabas si ano, si Xrealstat natin, yun ang gagamitin natin, no? Control M, ayaw. So, ibig sabihin, kailangan i-run ko ulit yung ano, Xrealstat. So, let's run Xrealstat. Gagamitin natin yung add-in na yun. I can use Alt T I, Alt plus T plus I, Alt, ayaw, Alt T I. Yan. Para diretso, guys. So, gumamit ako ng keyboard shortcut na Alt plus T plus I sabay-sabay para makuha ko kagad yung add-ins. Otherwise, guys, magpa-file muna tayo. Options, add-ins, matagal pa. No? Ulitin ko, guys, yung instructions, ha. Kasi nag-control M ako, control M, hindi na naman gumagana yung ano ko, yung Xrealstats, no? So we will have to use that. We're going to use that now. So shortcut, sabay-sabay Alt T I. Sabay-sabay dapat kasi nagkakamali minsan. Yan, nag-Alt. Hindi siya ayan, Alt T, Alt T, and then letter I. So we have the add-ins. Now, yun ang shortcut natin sa ano. Tapos, i-unclick ko tong Xrealstat. Okay. Then, Alt T ulit ako. Then, I. And then, click ulit siya. Okay. So, lalabasan naman si add-ins, guys. Yan na naman si Xrealstat. Or, Control M. Okay, so, pause muna ako. You have this. Okay, thank you. The rest, guys. Okay. So I hope you have it, guys. Pwede rin natin gamitin yung add-ins ni ni Excel, kaso sabi ko nga mas maganda tong add-ins ni Xrealstat. Okay, so you have here several functionalities, ang dami, no, compared dun sa data analysis ni Excel. So this is descriptive statistics, this is regression. So marami siya, no? Dami. ANOVA, time series, and then multivariate, correlation, etc. So let's choose regression. Okay. Multiple regression tayo. By the way, guys, sa simple regression, pwede rin natin ginamit to, no? Okay. Okay, so we have here, ano yung X output natin? X output, input natin are the independent variables, which includes education hanggang number of dependents. No? So highlight natin yon. Oops. I have a problem with my mouse. Okay. Dali escape ko muna. Okay. Input. And then input Y is okay, I hope we're on the same page. X natin will be from J1 up to P527. And then si Y natin will be Q1 up to Q527. And then the default is column headings. Sinama natin guys yung column headings. And then we're going to include intercept. Kasi pwede guys na hindi isama sa intercept, no? Okay, then you have here, ito guys, yung regression analysis, ito yung diagnostics, no? So we can put here, we can click na muna natin to para makita natin yung mga inalabas niya, no? Okay, alpha is at 0.05. And then output range natin, lagay natin dito sa, lagay natin sa T1. At T1. Okay, so far guys. And then, click natin OK. Ano nangyari? Ba't may mga plots to? Na-click ba ako ng mga plots? Okay. So you have the output, guys. Paki-chat nga kung okay so far. May I know, guys, if you were able to generate the output? Okay, thank you. The rest? Yung iba, naka-generate ba ng output? Okay, so I hope you were able to generate the output, no? Okay, let's take a look at the output, guys. You notice yung output na regression output ni ni Xrealstat is far more comprehensive than Excel. Mas marami siyang linalabas na na output. So, dito sa taas, okay. So, we have first multiple correlation, no? So, ito yung correlation ng lahat ng mga independent variables natin dun sa dependent variable natin. R squared is 0.37. So, sino mas maganda guys? Yung model kanina based on R squared. Sino mas maganda? Yung model kanina, yung simple, o itong model 2 natin? So, this is our model 2. Our model 1 is the simple linear regression. No? Ito yung model natin kanina. Ano yung R squared natin dito? So, it's just 16%, no? 16.5%. Dito, ang R squared natin, 37%. Kahit adjusted R squared, pag gamitin natin, 36%. So, sino, guys, sino mas maganda? Si Model 1 o si Model 2? Guys, answer? Based on adjusted R squared. Okay, Model 2. Thank you, Nicole. Model 2, no? Model 2, kasi mas mataas yung adjusted R squared niya. Ibig sabihin, yung model natin kayang i-explain 36% ng variation, ng variability ni HR wage, hourly wage, using our independent variables. Now we have here, guys, may mga nakikita dito, no? These are what we call information criterion. So meron tayo ditong AIC. This was developed by a Japanese statistician. Okay, sandali, sulat ko lang. AIC, this is called your Akaike, no? Akaike Information Criterion. So maraming klase yan, guys, no? Ito Akaike. This is also Akaike, yung C dito corrected. Yung small c dyan corrected. And this is your SBC, this is your Schwarz. Bayesian criterion. Okay, we won't go to the details, guys, but suffice it to say, ginagamit itong mga information criterion na to, in order to compare models. Sana umabot tayo sa isa pa, no? So, the lower the AIC, kasi this is a measure of information loss. Yung nawawalang information. So the lower the AIC or AICC, the better the model is. Okay? So unfortunately, guys, wala tayong computation ng simple linear regression. But definitely, guys, yung AIC niya will be will be higher than this one. Okay, so continuing, guys, adjusted R squared, sabi natin ito mas ginagamit natin pag multiple linear regression. Standard error 2.95 as compared kanina dito sa SLR. Standard error natin dito 3.37. So it tells us that this model is better kasi yung standard deviation ng mga predicted values natin, standard deviation ng mga errors natin is less. So less volatile. And then kita nyo dito, guys, so regression natin, degree of freedom 7. Bakit 7? Kasi we have 7 independent variables, 7 regressors. 1, 2, 3, 4, 5, 6, 7. Okay? We know this is just n minus k minus 1. So we have 526 minus k minus 7 minus 1, that gives us 518. This degree of freedom is simply n minus 1. Okay? Tingnan natin, guys, ito, SS. 2652. Yung SSR natin. Yung SSR natin dito is only 1179, no? So mas malaki yung variation, yung variability, mas malaki yung kayang i-explain ng model natin compared dun sa simple linear regression lang natin. So ang residuals natin mas lumiit dito, no? mas lumiit. Okay, clear so far, guys? So, 226.52 out of 7,160 ang kayang ma-explain. So, that's around 37%, no? Around 37%. Ang hindi kaya, 63, around 63%. Yun ang unexplained. This one divided by this one. Okay, let's go here, guys. This is just SSR divided by 7. This is just SSE divided by degree of freedom 2. No? Ito yun. Ginagamit natin to para makuha natin si FSTAT natin, no? Which is just this MSR divided by MSE. So that's 43. So this is just to verify. Okay, no? All right, p-value is practically 0, guys, no? 47 decimal places and then 253. Okay. So what's our null hypothesis here dito sa ANOVA natin? What is our null hypothesis? So our null hypothesis for our ANOVA is null is beta 0 is equal to beta 1 is equal to beta 2 hanggang is equal to beta 7 is equal to 0. Okay? So that's our null hypothesis. Lahat ng mga parameters natin, including the intercept, beta 0, beta 1, beta 2 hanggang beta 7 is equal to 0. Okay, what's our inference? What's our conclusion? P-value is less than 0.05. No? When the P is low, the null must go. No? So, conclusion, reject the null hypothesis. By the way, guys, paano ulit nakuha ito? F.this, .rt. X natin is your FSTAT, comma, degree of freedom 1, comma, degree of freedom 2. Okay. So that's how we got our F value. Right? And significant, yes. So we reject our null hypothesis. We say that at least one of these is not equal to 0. Okay, and then we go to the individual t-test of each of the parameters. So ito yung mga values nila, guys. Values nila. Standard error, t-stat. So ang focus natin itong p-value. Yung p-value, guys. Okay. So ang question, guys, sino dito ang mga insignificant? Remember, ito, guys, may test to. No? Ano yung test dito? Sulat ko ulit. The test here is, so HO1 beta 0 is equal to 0. Ano ko ngayon, So, kay education naman, HO2 beta 1 is equal to 0. Null hypothesis number 3 natin, beta 2 is equal to 0. This is for education. This is for experience. Okay? So we have to make inferences about these individual tests, no? So makikita natin yan dito sa p-value. Highlight ko to. Okay, and let me do conditional formatting, home, conditional formatting, highlight cell rules, greater than, so 0.05. Yan na lang. Okay. Alright, sino dito yung mga greater than 0.05? Sino dito yung mga greater than 0.05? Yan, yung mga naka-red dito, no? Si experience, si non-white, si married, si number of dependents. Okay, ibig sabihin yan, guys, hindi sila significant. They're not significant. In fact, if you take a look at the, upper and lower confidence interval, sabi natin, di ba, tatamaan 0. So possibly ang values niyan 0. So kung 0 yung mga coefficients niyan, then wala siya, effect kay wala siyang effect kay hourly wage. Okay? So, ilalabas na hindi natin isasama tong itong mga coefficients na to. Therefore, our model for this one is susulat natin yung model natin. Ang kasama lang guys yung mga significant variables. So for this model, hourly wage is equal to yung intercept natin, negative 1.998. Ano ko na lang guys, drop ko na lang yung decimal places. Now take note guys that the intercept is significant, no? Okay, 0.01, less than 0.05. However, kahit na naging greater than 0.05 yan, sinasama pa rin natin siya. And then we have 0.58 times education. Education is still significant. Plus, sino pa? Tenure. 0.13 times tenure. 138 times tenure. Plus, female. Negative 1.75 9 times female. So we have plus an error term. So that's our model, guys, based on our multiple linear regression. Now, take note, guys, pag ginawa ko tong hourly wage na to, pag kinuha ko na yung predicted value, negative 1.98 plus, so para education, plus 0.138 times tenure, plus negative 1.759 times female. Okay? Mawawala na yung error term. Kasi exact na to eh. Ito guys, yung this is the actual value. Ito yung predicted value. So hindi siya magiging possibly hindi siya equal dun sa actual, kaya naglalagay tayo ng error term. Para maging equal yung predicted, bali ganito, no? Yung actual value natin is equal to the predicted plus a certain error term. Kasi hindi naman maging eksakto yan eh. So this is the actual value, this is the predicted value, plus the error term. Pero pag naglagay tayo dito, ibig sabihin predicted to, tatanggalin na natin yung plus error term. Kasi predicted yan eh, eksakto yan. Okay. So, interpret this guys, ano ibig sabihin nito? So negative 1.98, sabi natin, that's the value of the hourly wage when all the parameters are all equal to 0. So walang education, walang tenure, walang male, no? Kasi 0 si female, ibig sabihin male yan. Okay, so that's the meaning of negative 1.98. Okay, ano ibig sabihin ng 0.58? 0.58 guys, ibig sabihin, for every 1 year increase in education, there's a corresponding 0.58 dollars increase in hourly wage, comma, ceteris paribus. Ano ibig sabihin ng ceteris paribus? All things being the same, all things being held the same. Ibig sabihin, hindi natin papalitan itong mga to. Yung tenure, hindi natin papalitan. Ang papalitan lang natin si education. Okay, ibig sabihin ng tenure. Okay, 0.138, ibig sabihin yan guys, this is the marginal effect of tenure on hourly wage. For every 1 year increase in tenure, there's a corresponding 0.138 dollars increase in hourly wage, ceteris paribus. Okay? Clear so far, guys? Pa-chat naman kung clear. Okay, thank you. Good. Okay. How about this, guys? Ito, negative 1.759 female. Ano ibig sabihin nito? Okay, now, this is not the important thing, guys. Ano? Doon sa pagpili natin kung ano yung base or reference factor natin. Remember, guys, ano yung base factor natin? Sa gender. Ang base factor natin, di ba, yung male. Ibig sabihin, si male ginawa natin 0. So when we interpret this, itong negative 1.759 na yan, this should be interpreted in relation to your reference factor or your base factor, okay, which is male. So ang ibig sabihin nito, on the average, female employees receive $1.759 less, kasi negative, less than their male counterparts. Okay? So yung mga dummy variables, guys, that is always interpreted in relation to your base or reference factor. Ulitin ko si female, guys, dummy variable yan kasi categorical variable yan eh. So when we interpret the coefficient for female, dapat yan i-interpret natin in relation to the base, which is male. So that means yung negative 1.759, ibig sabihin, on the average, female employees receive $1.759 less, kasi negative nga, compared to their male counterparts, and then comma, ceteris paribus, all things being the same. So that's how you interpret that, no? Okay, ganoon din yung iba, yung ibang categorical variables. Okay, kunyari ito. Kunyari guys, itong married. Assuming na significant siya. Hindi kasi siya significant, ano? Ang ibig sabihin nito, if this was significant, on the average, married employees receive $0.459 of more, guys, more, in terms of our hourly wage compared to their single counterparts. Yun ang ibig sabihin nun. Ito, sampa, non-white. Ano ibig sabihin nito? On the average, non-white employees receive $0.10996 less than their white employee counterparts, comma, ceteris paribus. So that's the meaning of that, guys. Okay? Now we have a few more minutes. So we will discuss this, ito guys. Ito pang test ng normality, no? Okay, then we have here, ito guys, ano tong mga ano na to? Ano yung MSE na yan? Ito lang yan, no? Mean square error. Okay, ito yung K natin, yung number of independent variables. Degree of freedom of your errors, no? Sum of the squares of your errors. So, summary siya ng regression statistics natin. Okay, question. Is this the final model, guys? Is this a final model? No. No. Eh di ba mga insignificant na to? Yes, they're insignificant. Pero, hindi natin kagad sinasabi na ito yung final model. Kasi, ang gagawin natin guys, isa-isa natin tatanggalin yung mga insignificant variables. So this is how it goes, no? So, kindly listen. So meron tayong 4 na insignificant. Ang gagawin natin, magsi-stepwise tayo. We will now create another model na tatanggalin natin yung isa dito. Ano yung magiging basis ang tatanggalin natin? Tatanggalin natin guys yung pinakamalaking absolute value ng T-stat. So titingnan natin si T-statistics. Okay? Ito. Hindi, regardless of whether it's negative or positive. So this is 1.78. This is 0.25. This is 1.5. This is 1.3. So ang pinakamalaking T-stat is, sorry, ang hahanapin natin guys yung pinakamaliit kasi yung pinakamalaking T-stat yun ng relatively pinaka-significant sa mga hindi significant. No? Ang hanapin natin yung pinakamaliit na t-stat. So in this case, ang pinakamaliit na t-stat natin dun sa mga insignificant is 0.25. So what will happen now, guys, is we're going to create another regression model. Okay? Tatanggalin natin si non-white. Okay, so may I have just, guys, 2 minutes. Okay lang ba? Papakita ko lang sa inyo kung anong gagawin natin. May I have your permission, guys? Just 2 minutes. Extend ko lang ng konti. Pwede? Okay, thank you. Thank you, guys. Okay, so, i-copyhin natin ito, guys. Copyhin natin ulit yung data natin. This one, Control-C. Copy natin dito. Control-V. Okay? So, we're now going to create, lagyan ko lang ng ano to, ng field para separator. Okay. Sabi natin, mag-create tayo ng another regression, tatanggalin natin si non-white. Delete. Bakit siya dinelete ko, guys? Kasi siya yung pinakamaliit na t-stat. Siya yung pinaka-insignificant sa lahat ng mga to, no? Sa lahat ng mga insignificant, no? So tatanggalin natin yan si non-white. Ang tawag sa kanya living variable. And then magre-regress ulit tayo. Yung ginawa natin kanina, guys. So Control M. Okay, regression, multiple regression. Okay. Then this time ang input range natin hindi na 7, 6 na lang, no? Kasi tinanggal na natin si oops. Categorical variable na non-white. There. Tapos si y natin, yan. Tapos, huwag na natin muna ilagay yung iba, no? Ito na lang muna. Tapos output natin, lagay natin sa BM1. Okay? BM1. Okay. So we have another regression, guys. Another regression. What happened? What happened, guys? Adjusted R-squared natin 363 dito 361. So lumaki, guys, yung ano natin, no? Dali liitan ko lang to para side by side natin. No? Okay, 363 ito, guys, 361, no? Also, Akaiki, guys, 1144. Ito, 1146. So based on that, sino mas ano, guys? Sino mas maganda? Si Model 3 o si Model 2? Si Model 3. By virtue of having a lower Akaiki information criterion and also a higher adjusted R-squared. Tapos, again, significant ba, guys, yung overall model natin? Yes. Take note na 6 na lang yung regressors natin. Okay? And then, again, titingnan natin dito, guys, sino yung mga significant? Home, conditional formatting, highlight cell rules greater than 0.05 natin. Okay. So this time, guys, ang model natin, may iba na yung mga values, no? This is another model. And ang insignificant natin, itong tatlong to. So we'll create another model for this. And then anong gagawin natin, guys? Do we stop with the model? Yun na ba yung final model natin? Hindi pa. Anong gagawin natin? Hanapin natin kung sino yung tatanggalin natin. Which of the variables are we going to remove? We're going to remove, guys, that with the lowest t-stat, which is number of dependents. Ito. Tanggalin natin to, guys, tapos gawin ulit. Now, may I request you guys to do that as an exercise. Ituloy-tuloy nyo to, guys, hanggang wala nang insignificant, hanggang significant na lahat. Okay? And that's what we're going to discuss this coming Friday plus another topic. No? Of course, with R plus another topic. Okay, so thank you so much, everyone. Sorry for the extension. I hope you learned something today. So I'm going to see you on, if you're free, kindly be there in class on Friday. Okay.